Welcome to Understand the Math. In this question, we're asked to find the eigenvalues of this given matrix, and it's a 2 by 2 matrix. We're going to solve this problem by solving the equation determinant of a minus lambda I is equal to 0 for lambda. And then lambda is going to be our eigenvalues. Let's go ahead and set this up. Let's first compute a minus lambda I. That's going to be our matrix 4, 2, minus 1, 1. And then we're going to subtract off lambda times our identity matrix. And this is going to give us 4 minus lambda, minus 1, 2, and then a 1 minus lambda. So that's a minus lambda I. Now what we're going to do is find the determinant of that matrix, and we're going to set that determinant equal to 0. So we have the determinant 4 minus lambda, minus 1, 2, 1 minus lambda. We can indicate the determinant by just drawing a straight line, and we're going to set that equal to 0. Now, to evaluate the determinant, what we're going to do is we're going to multiply the main diagonal, and then we're going to subtract off the off diagonal. So this is going to give us 4 minus lambda times 1 minus lambda minus a minus 1 times a 2, and that's equal to 0. Let's go ahead and multiply this out. We're going to get a lambda squared minus lambda minus 4 lambda plus 4, and then we have a plus 2. Let's combine like terms. So we have lambda squared minus 5 lambda plus 6 is equal to 0. Now what we have to do is factor this. Notice that we have a 5, and the multiple of 6 is 3 and 2. So we can factor this as lambda minus 3, and then lambda minus 2 is equal to 0. So this gives us lambda minus 3 is equal to 0. And from there, we get that we have an eigenvalue lambda is equal to 3. And then we can set lambda minus 2 equal to 0. And we get an eigenvalue lambda is equal to 2. So our eigenvalues of our matrix are 3 and 2.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.